Okay. Good morning, everyone. Um, so welcome to week 9, right? So this week we'll be covering regression and clustering, right? Two different techniques we'll be going through. Okay, I just need to.
स्टार्ट होगी.
Yes. Can you hear me? Is the sound okay?
Yes, sir.
Okay. So I'm recording the video so that later you can, investigate that. Last week we did the so the first thing, classification, right? Always remember that in machine learning it starts from classification, and I uploaded that video, so you'll find that video in when you enter to the course page, right? So the video is there, and feel free to look at that video, and because that is a starting part for the assignment, final assignment. Okay, and this particular lecture is also the second half of the assignment, right? So in summary, these two videos will guide you towards the final assignment. Okay, what is regression? Now, if you can recall from the previous lecture, is that when we have a table of data and we need to identify a class, a particular class of output, for example, diabetes or a disease, right? Cancer disease or anything, or identifying a leaf, a particular type of leaf. Those examples we went through, and those examples are giving the conclusion that based on certain conditions, this is the type of species, right? And the output is fixed. Either the output is what type of leaf and so on. Okay, so just need all. So either what type of species or what type of leaf or what type of image, right? Or is the patient happened, yes or no? So all these are called classification. This week, we will look at an interesting example of when the conclusion or the decision is a number, right? We'll see that example, okay? And that is actually the regression thing. So this particular test data, my house.arff, or sorry, house.arff is actually given in week 9 lecture. So if you go to the week 9, then you'll find that the data is given under week 9. So what is this my house? I just show you the screen size, sorry, the screenshot. Later I'll run the program in WEKA, right? So if we open the house.arff file, so you can see here, right? Just one thing. Okay. So this is the file. Sorry, chart file. Okay, so this is basically the file, right? So this particular file, when we load it, we can see these particular parameters, right? These parameters. So we can see that house size is one thing, a lot size for a particular property, bedrooms, how many bedrooms, right? So this is an interesting one, like the bedrooms, 2 bedrooms, 3 bedrooms, 4 bedrooms, and so on. Granite, is the granite is there or not? How many bathrooms are there? And this is the conclusion, selling price. So based on these conditions, this is the selling price of the house. Okay. So this is the data. Okay. Now, what this particular, program is trying to do is that if I get a list of houses, for example, 20,000, 30,000 houses, in which in the database, all these house size, lot size, bedrooms, granite, bathrooms are given and the selling price is given. So my program will try to learn those data, and then in future, if I want to, ask that, okay, what is the price of a house based on this data, then the program will identify that. Okay, so that is basically the idea. Okay, so we'll see these examples. So once we load the data under pre-process, so under pre-process, basically we load the data, right? Then we go to the classify tab. So remember that last class we also did the classify, right? So this classify we also did. This time the same tab will be going through. So under the classify tab, so you can see here that you choose the button functions. So I choose the functions button, and then there is an option called linear regression. So this is the one, linear regression, right? So when I click the linear regression, it will give the output. It will generate and it will give the output like this. Okay, so this example I would like to go through. Um, so we can see here is that when I do it, the selling price is a equation, right? Is a equation. So equation consists of like house size, lot size, bedrooms, bathrooms, and so on. It can be different as well. It can be maybe all the parameters or selected parameters. So this program will make the equations out of all the data, right? And so when I do it, right, so then an interesting thing really will happen here. So I'll explain that after a while. I need to really draw something here. Uh, let's see if I can do it because my pen is not really working. Okay. Um, so I just try to draw. Okay, I'll try to give the example later on. Using a whiteboard probably. Let's see. Um, um, so, for example, if I say that this is a graph, right? In which this is the house price. Okay, this is really difficult. Yeah. Um, so this is the house price, like H dot P is the house price. And this is probably the, say, lot size, L size, right? So I can say that this is the lot size and this is the selling price. So in this graph, we are showing really two attributes, right? Two attributes we're only showing. And then we have thousands of data. So in one of the data, for example, suppose the lot size is, this is the, say, 1, right? This is 2, this is 3, right? And this is say 6, right? And this is 7. Okay, and for one bedroom size, suppose one example I got here, this point. So this point is probably say two 100K, right? This is 3. This is say 5, 500K or something like that, right? And you have all the data. Suppose these are the data. These are all the data. Some of the data are really, kind of, so something like that. Okay. I think it makes sense, right? Any question on this graph? Just one single respond. Is it fine to understand this graph?
Yes.
Either, yeah, okay, fine. Now, what these clustering is doing, okay, I'm just showing it in a graphical, in a very simple manner so that, you'll understand it really clearly. Okay, so what's happening here is that uh, it try to make a line. Now, this line is not a straight line. This line can be straight line, this can be. Now, there's a mistake. What I did is that when I select the linear regression, so you can see the word linear, right? So linear, the word linear here means a straight line. So in linear regression, you will always get a straight line, but there is quadratic regression. There is complicated multinomial function regression in which you can get a very complicated line. Okay, so our focus, our lecture will be based on linear regression to make it simple. It is not really simple because linear regression is widely used in the industry in most of the kind of data analysis. Okay, now, so again, coming back to this example, that based on this point, our program, this particular algorithm of linear regression, will try to make a line which try to fit most of the point. Okay, so I just try to make it understand that I'll try to make a line which will try to fit as many points as possible in that line, or the points can be very close by. For example, I want to make a line, say, just try to this. So this is a line. So when I draw this line, I can, and some other people, another people made a line. I mean, it's really hard for me to, but this, suppose there are two different lines, right? Okay, let's see for the, or maybe for sake of argument, I mean, I just delete the first one. Okay, so this is really a good line, right? Okay, so from this line, I can see that the first point, this is the distance, right? Can you see the black line? So this black line is the distance, and now there's a two different term, that the red line is actually the predicted point, right? So I can see that this is this point where my mouse is, the cursor is actually the predicted point, right? This one is the predicted point, but this point is the actual point that was in the data. Okay, so I think all of you are following, right? So I'm just trying to make a point. So this point is the predicted point, but it's to be very big. But this point is the actual point. Okay. So the again, what's happening? Okay. So try to understand here that this point is the predicted point, but this point is the actual point. So what I'm saying, that this point is the actual point that we expect that our algorithm should identify this point, but our algorithm, this program actually identified this point, right? So this distance is actually the error. Does it make sense, everyone? This distance, this black line is actually the error. Error means the mistake that our program did to identifying a point. Does it make sense, everyone, about the black line? I mean, everyone need to give an attention on this. Do I need to repeat or is fine?
Can you repeat one more time, sir? Thank you.
Okay, so what I'm saying is that this point is actually the predicted point, what our algorithm predicted, right? Can you see my mouse? But this point is the actual point, what this program should reveal. Is it okay?
It's okay.
Yes, sir.
Got it
Yeah.
now. Thank
Yeah.
you.
So this distance is actually the actual error that I'm trying to say, is the error of the program, right? Now, you can try to think that we should try to make a program in which it will draw a line so that the error is very minimum. So if the error is very minimum, our program is the most accurate. This accuracy thing I'm focusing on because this is really the discussion that you need to put into the report after doing all the experiment, all the program that in the WEKA you'll be doing. But this type of discussion you need to really do. Okay, now what are the other errors? So suppose this point, can you see this point? So this line is another error. Am I right? This distance is the another error. This
Yes.
distance is another error. Is it okay?
Yeah, it's okay. Clear.
Excellent. So this distance is another error. 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 Of course, I'm recording the video. I'll later upload it into the home page of LMS, right? At the entry point. So you can revise that if you miss anything. This distance is another actual error. Okay. Um, now just try to understand that. And also, yeah, that's true. So you have to make all the kind of summations, all the summations of the error is actually the actual error. So you can make a summation of all the distance, right? This distance, this is the actual error of this particular program. Now, suppose another algorithm revealed another line. Suppose that line is, say, this line. This is another line. So now just try to understand that what is the actual error in this case. So in this case, the actual errors are what? Like from this point is the actual point. This is the predicted point. So this line is now the error. This line is another error, right? This line is another error. 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 This line is another error, and this line is another. All makes sense? So you can see that this is the distance from the actual points. So for this second line, the summation is really bigger. Now, if another program make a line like this, now the distances are pretty much huge. Am I right?
Yes, sir.
Okay. Now you got three lines from three algorithms. So by calculating the distance, I can find that that this line is the shortest distance, like all the errors are minimum. So I can simply cross this line and cross this line. So they are not the closest line. So I can say that this line, like this line, this one basically that I'm talking about, is actually uh, the closest or the most accurate, and maybe this line's equations is this. This is the equations of this line. Did you understand the idea or not sure?
Yes, sir.
Okay. Now, one thing I missed to tell you that in the graph, we talked only the lot size, but we have bedroom. So bedroom is actually the three-dimensional point. Bathroom is four-dimensional point, right? So the three-dimension, four-dimension, I cannot draw so that I cannot explain. But you can imagine if there is a three-dimension point, like this is the lot size of x dimension, and this is the bathroom size. This is the bathroom of z dimension, right? This is the z dimension. So then these points are actually the floating. Floating means in the 3 dimension, all the points. But in the 3 dimension, you can make a line, a straight line, and calculate the shortest distance. Now, in 4 dimension, that we cannot see, we cannot visualize, but we can imagine that it's a 4 dimension in which there is a straight line, and then try to make a straight line which is close to all the points, right? So what I'm saying is that this particular equation result is actually 1, 2, 3, 4. It's a 4-dimensional linear line in which I can predict the selling price of a house. Okay. Now, I mean, if you really struggle to understand this 4 dimension, 5 dimension, the graph, this graph is actually for the real understanding what's actually happening mathematically, graphically, right? But this graph is not important for you. But if you can understand, you will find the joy of understanding that equation, right? So what I'm saying is that this is the equation that you need in real life. In real life, you don't need the graph. This graph is only for understanding the whole concept, right? That's why I'm recording this video so that you can read it, look at it again so that you can understand what I'm trying to say. But this equation is the most important component to give the decision. And you can see, and now I'll go through that equation thoroughly. Okay, so far, any question from any of you? You can ask the question or you can write into the chat. All good, kind of, everyone?
Yeah, all good.
Okay,
Understood.
so now coming back to the selling price, this is the most important thing, selling price. So in selling price, I can see that minus 26.68 into house size, blah, 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 all this, right? Okay. Now, suppose this program is patent and all the points are very close by from the existing data. So in future, if I get a data that I have a house size of 60, lot size of 5, bedroom of 3 bedroom, 2 bathroom, then what is the selling price? What the real estate should decide? The answer is that you put all the value here. Suppose house price is say 40. So 40 times minus 26.68 plus lot size is 5. 5 times this. 3 bedroom, 3 times this. 2 bedroom, 2 times this plus this. This will give a numerical number. And this is the predicted house price. That should be the reasonable predicted house price. Okay, I'll give that example next slide. But what I'm trying to say is that I already discussed the 3 different lines, right? And the middle lines is the best line because this distance is the shortest distance. And this distance is actually this figure, root mean square error, this one, 4053. Right? Mean absolute error. So mean absolute error is actually indicating the accuracy of the algorithm. So if I make 3 different lines will have 3 different mean absolute error. So the mean absolute error, which should be the minimum among 3, you have to select that model. Does it make sense about the decision? So, right, so among these 3 or 4 line, which has the shortest mean absolute error, you have to pick it as the equation. So for this particular straight line, actually this is the mean square error. Okay, and this is the equation. Okay, now I'll go through probably and some ideas. So look at this example, then it would give you the understanding clear. Sorry, just okay. So look at this particular output. So step 3 is interpreting the regression model. The regression output is selling price equal minus 26 house size. So this is this equation. I'm talking about this equation. right? So this particular equation of regression output is actually this one, same thing, right? So this one I just wrote it, right? This circle one I just wrote it here. Now suppose I got an example of this is just an example of 2983 is the house size and lot size equal to 9365, bedroom 5 bedroom, bathroom only one bathroom, right? So then I can get the house prices. When I do it, I get the house price of this one, which is 222921, right? So plus actually minus this, right? Minus this. There's a mistake. So this equation, if you put all the value, you can get this price, right? 2 grand, 2022 $1,000. It is a Canadian house, Canadian dollar, or their kind of price. So this is how this algorithm of linear regression always predicts a number. So I think it's now clear that what the regression is doing. Regression is always predicting a number. And what is how the classification and the regression is different, I think it's now really clear, right? In classification that we covered last lecture, we predict what type of class it is. Is it a particular species? Is it good or bad? Is it yes or no? But in regression, we always predict a number. We always predict a figure, like what is the predicted weather, what is the humidity, what will be the temperature, what will be the air pressure. So these are all regression type of problem, right? Okay, so again in regression we try to predict a number. Okay, now this discussion in step 4 is really vital for your final assignment. Remember that. Okay, before going there, I just want to investigate something from this equation. Okay, so remember, these I really need your attention right now because this discussion is really, really vital. Of course, you can read it the video that the house size, lot size. So house size is the first parameter, right? Lot size is the second parameter. Bedroom is the third parameter, and bathroom is the fourth parameter. Now, the question is, which parameter is the most powerful to make a decision, right? I just try to
House
make a,
size.
sorry,
House size.
house is okay. No, that's okay. We'll see that. We'll see. I mean, from this equation, how to find that thing. Before going there, I want to write an equation, for example, like 2x plus 10y. This is the equation, okay? And this gives a value, right? Something, okay? So if x equal to 1, suppose x equal to 1 and y equal to 1, what is the value? 2 plus 10, 12. Am I right? Everyone? Makes sense, right? Yeah. Okay, so I just, yeah. Okay, 12, good. Now, just try to understand that if I make y, so which one is giving what? So just try to understand that if I make y 2, right, and x equal to 2 as well, then what is the value? 2 times 2, 4, 20, right? This is 20 plus 24, 24. Now, 24, good. So just try to understand that on the result, which one is giving kind of more emphasis. So out of 24, this is 24, right? Out of 24, in fact, 20 is coming from the y component. Am I right? Are you following?
Yes, sir.
And only 4 is coming from the x component. Then which variable is giving the more value in the overall result? Of course, y. Are you following? Did you understand what I'm trying to say?
Yes.
right? So which I'm saying that if you increase the y, now this is the main point. If you increase the y, it will have greater impact than if you increase the x. Does it make sense? So suppose y equal to 2 and x equal to 3. What is the result? Can you tell me? 3 times 2, 6, and 26, right? 26. Good. Some of you already wrote in. Okay. However, so this is the 26. Okay. But if I make x equal to 2, but y equal to 3, then what result I am getting? So I just reversed it, right? 34. So can you see that the overall number quickly improves if I increase the y compared to the x? Am I right? Make sense? Do I need to repeat or it's fine? I mean, if you ask me, I can repeat that.
All good.
Sorry? Should I repeat? Okay, just these two examples. Suppose if I put 2 and 3, so if I increase the y, then the result greatly increased, right? The overall impact. But if I increase the x, because it's only have a small coefficient, the result will not be impacted much. But since y has a bigger coefficient, if I increase y, the result will grow quickly. Does it make
Yeah.
sense, everyone?
Yeah, got it. Yeah.
Okay, so if you understand that, then you 100% understood the regression. Okay, so now look at this equation. Which coefficient is the highest? So sorry, look at this data, then it should be easier for you to understand this equation. Which coefficient? So house size coefficient is 26.68. Lot size is this. Bedroom is a big number, right? And bathroom is also a big number. 422, but bedroom is the highest coefficient one. Are you following, everyone? So that
Yes.
means that if you increase the bedroom, the total house size will increase quickly. Similarly, if you increase the bathroom, it will increase quickly. But lot size, if you increase that, it will increase not much, right? A little bit. House size is an interesting features here. It has negative coefficient. Can you see the negative number? Minus 26, right? Minus 26. So if you increase the house size, it actually lowers the price because it is a minus. So it will do the overall minus thing and the total price will go down. Are you with me?
Yes, sir.
Yes.
Okay, so
Yes.
this is interesting. So it
Yeah.
actually indicates that suppose you have a big house size, but your bedroom is smaller, for example, bathroom is smaller, then this price is not that good because of the negative coefficient. I think it's understandable, right? What I'm trying to explain.
Yeah, it is understood.
Okay, and secondly, another very important thing, go back to the data again. Go back to the data again. So in the data, we see that there is an interesting data was granite. Sorry. So there is interesting data of granite. Are you following, everyone? Granite is there. So granite has a data, but in the equation, when I generate the equation, then there is no granite thing. Can you see a granite here in the equation? No, there is no granite.
No granite. Yeah.
No granite, which means that if you put a granite or if you do not put a granite, it doesn't have any impact on the house price. Are you with me? So granite data is not relevant in house price in this particular case. This point, try to understand pretty much, in depth. Does it make sense? Otherwise, I can repeat this granite information.
Yeah, it is
Hope it makes
straightforward
sense.
because it's an addition.
Correct. So I didn't understand what you're saying. If the
It is
eco,
an addition. If the house is made of granite, it will increase in value.
excellent. So what I'm saying is that if there is a granite or there is no granite, it doesn't have any impact on the house price, okay, on the regression output, right? Excellent. So now some conclusion I'm just going through is that, look at that, granite doesn't matter, right? So this is the interesting thing, granite doesn't matter. Bathrooms do matter. Why bathrooms do matter? Because if you, sorry, bathroom matters because, if you increase the bathroom, it has a big coefficient. Also bedroom matters, and house size negatively coefficients, right? It will, so bigger house reduces the value. Why bigger house reduce the value? Because the bigger house has a negative coefficient. Can you see the negative 26, minus 26? So minus 26 is the house size. So if you increase the house size, it will be a big number in a minus. So the overall price will go down, right? And I think it makes sense, right? And granite doesn't matter. And what else? Yeah, that's it. So these are the three conclusions. And these similar three conclusions that we just went through, that you need to identify from your regression equation in your discussion part. Any question up to this point? Do you have any question up to this point? Okay. Now, some extra example of no need to run any array, only look at the output and think. Okay, so now some exercise I'm going through. Only look at the output and think, how can you interpret the linear regression model of the next page, right? So this is the exercise kind of thing, because you need to understand mainly from the result. Okay, let's see an example. Suppose I ran a program. I think you can see that, right? So this is the house price. Okay, this is the house price. And I can find that this is the data came. That zip is the postcode of a country to get the house price, right? The price of a house. Bedroom size, bathroom size, something half, some type condo or single type of, it has a big coefficient as well. Single, it has this, square feet and lot, and this is a coefficient. Okay, now tell me, which coefficient is the highest of this particular data? I need your answer. Bathroom, right? You can either you can answer or
Bathroom.
you can type. You can type in the chat. That's convenient. So bathroom, right? So bathroom has the highest number. Yeah, you're right. So bathroom has the highest number, which means that bathroom has the greatest impact. Am I right? Bathroom has the greatest impact. Okay. Now, what else? That what about what is almost close to zero? Which one you think close to zero is lot size? Can you see that lot size is very small coefficient, right?
Yes.
Minus 0.07, almost
0.01.
close to zero, which means that lot size doesn't have any impact or very, very negligible or minimum impact. So if you increase the lot size, but if you do not change any of this data, then the total price will increase like $1, $2. Am I right? Are you following?
Yes.
Yeah, because
Yes.
this coefficient is really, really very small, which means that from this small model, you can really cancel this particular attribute. You can do that. If it is, you think that this coefficient is very negligible compared to the other coefficient, you can simply ignore that, which means from your big table, sometimes by looking at the coefficient, you can delete those figure completely to make it simple. You also try to make it simple. Um, does it make sense what I'm trying to convey, the message? like the lot I can discard because it is close to 0. Okay. And also, okay, can you give the third point is what about the type single thing? What do you think about the type single? Is it positive or negative, the coefficient?
Negative.
Negative, right? It's a negative coefficient, minus 24, a big number, which means that if you take the type single, if you increase that, it will lower the price heavily. Am I right? It will negatively impact the type single, right? Okay, so this
Yeah.
type single is completely opposite. So if you get type single more, your price will go down. That you don't want, right? So try to understand. And also, bedroom is a negative coefficient. Can you see interestingly here? So even bigger bedroom, it can reduce the price. So this is a really interesting figure. But bathroom has really positive coefficient. Also the half, if you increase that, it will go down. Okay, I think anyone have any question of this particular data? Also the zip code, interesting. So if you increase the zip code, then probably the house price will go down. Okay, so that's another really interesting observation. So by looking at the data, you need to, give the decision of what you can achieve, right? And this is the mean square error, 2536 of this particular model. That's fine. So always this algorithm identify the shortest. So your job is to understand this particular equation and to understand every impact and write down the explanation in the way this explanation was given. So you'll find everything in the PowerPoint. Okay, so you can use that particular thing. Okay, so this is the first example. Second example is this equation, sorry. And then I remove the attributes. Can you see the remove the attributes? I remove the attributes, I make it only simple, only 4 attribute. So previously there was many attribute, but I deleted some of the unimportant attribute like the lot and other things, and I got only this 4. I keep the lot. It's another data, that's why. So it's a separate data. But when I remove that, then I run the linear regression again, I get a very normal equation like this. 3 is 88 into square feet. So equation is only depending on one attribute. So out of this 3 attribute, bedroom, square root, and lot, the ultimate regression model depends on only the square feet, only the second one, right? Sometimes it can happen. So then you don't need any discussion. So whatever bedroom you use or whatever lot size you use, it doesn't have any impact on the price, right? So this is another important point, and so on. Okay, so auto MPG is another data. Auto MPG is actually the price of a vehicle, price of a car. Okay, so the price of a car, no, sorry, this is actually MPG, mile, how many, kilometer or distance it covered, MPG, is this equation. Okay, now, which one has the highest coefficient to calculate the MPG? Can you tell me which one? From this equation, which one is the highest coefficient? It's very small number, right? So origin 1, 2, 3, excellent.
Origin 2, 3.
Excellent. And these are the negative, right? Cylinder, horsepower, weight, these are negative. So which means that if I increase that, the MPG will go down. MPG is less. But if the year is high, then it will increase. Origin has the highest impact, right? I think it now makes sense. You can calculate all the equation based on this particular thing. Okay. So now for the next, I pause it here. So for the next next 1 hour, please, I'll run an example, and you'll try to experiment that into the WEKA, and and try to understand, right? And any question, please try to um, write into the chat. That should be the best. Okay. So I'm just trying to do one thing first. Sorry. Let's see if I can get anything. No. It's in a different way. Okay. Okay. The first thing that I did is I opened the MPG data. So these data, I'll show you that into the Moodle, you'll get it. So all the data is there. So what I really did is I go to the classify, right? And I select the functions and linear regression, right? And use all training set. And now this one is the MPG I would like to do. So can you see in the column that number? So you can predict any of these. So I just select the MPG and start. So this is the equation. You can see that, right? This is the equation. So this is one equation of predicting the MPG. Now you can actually predict other things. So suppose you want to predict the say origin, and then start again. Then for the origin, you can get its own equation, which means that you can actually now I think you understand the difference between clustering and the the classification and the regression, that any numeric figure you can actually predict based on other data, based on other data. So what I'm saying is that if you look at the data here, share the screen. So if you predict the data here, right? So I can predict the origin on the right side. I can also predict the middle figures as well, like the house power, or the horsepower, or the acceleration numeric figure, cylinder, anything I can predict based on other data. So I can actually select any column as a conclusion, as a decision, based on it is a numeric figure or not, right? So that is I'm trying to say. So that's why I go back to this Explorer again. So I can predict any of this number. So I can go to classify, and I can see from here that which one is the number. So number is selected on the left side, which means that I can predict any of these. I can predict the weight of the car. I can click the start. I can see the weight depending on this factor. And in the weight of the car, I can see that, for example, acceleration is the highest attribute. So if you accelerate more, the weight is bigger. Or horsepower, if you increase more, the weight becomes bigger. But MPG, if you increase, weight becomes smaller because it's a minus negative coefficient. Everyone is clear about that? So please do that on MPG data. Now I'll show you what you need to run and make a doc file of all. So for every run of every decision, you just take the screenshot and post it into your doc report, right? That you need to upload in the lab work, everyone, right? Today. So so I will show you the thing that you have to do. Sorry. So I share the screen. So if you look at in the course, I think last lecture I uploaded it here, week 8. So this lecture I'll upload week 9 here, right? So you can see the video, recorded video. Now under week 9, you can see that there's a regression cluster file. So in this example, can you see the auto MPG ARFF, BMW browsers ARFF, and my house ARF, these three file, right? So I'm just writing into the chat. So what is your task of today? Chat, I'm just writing it. So auto BMW ARFF and dot ARFF. So these three files, analyze and run regression, take a screenshot, and discuss, right, in a doc file and upload. Okay, so in upload, so you can see that if you go to here under week 9, there's an upload folder, right? You can see that. So in which you have to upload that discussion. Okay, everyone is clear about what to do? So I'm just sharing the screen, then you'll understand what I'm trying to say. So can you see that data? That from the data, you can run these. So if you go there, you can find under week 9, these three data, you download that, you run that into the WEKA and do all the experiment, analyze and learn in linear regression, take a screenshot and discuss in a doc file and upload it. Is it okay, everyone, about today's work for the remaining time you have to do? All good?
Yes, sir.
Excellent. Okay. So just, no, all three, right? You spend all the time. So if you do all the three, your skill would be improved. You'll have the full confidence of what you're really trying to do in all the data set, right? Okay. And if you are not sure about what to do, please download this PowerPoint slide. Can you see the regression? The last PowerPoint slide, you'll get all the screenshot. Then you can understand the way you need to discuss. Every discussion is given there. Okay. Any question, just ask in the chat, right? Okay. So please try to do the coding, right? Okay. Thank you.